Okay, so the figure below, not drawn to scale, is made up of two identical quarter circles and two identical semicircles. Find the parameter of the shaded part. Take pi to be 3.14. Let us figure out what are the segments that made up the parameter. We have this quadrant here, the quadrant here, both will add up to a semicircle. Next, this small semicircle here, and then this small semicircle here. Again, these two will add up to the circumference of a full small circle. And last part, which is the vertical length. Let me change it to a highlighter. This radius of the quadrant, and then this part. Okay, which happens to be 8 cm also. Let's write down the obvious length. So this is 8 cm. Over here, what is it? Since these two quadrants are identical, if this is 8 cm, this must also be 8, which means this is 8, and therefore this must also be 8 cm. Okay, they are the same length. We can denote it by this. Okay, so let's now figure out the parameter. So we can first find the circumference, alright, of the big semicircle. What is the circumference of the big semicircle? We need to halve it. Half times, it's a pi, 3.14 times the diameter, alright? Circumference is, oh, I'm spelling wrong, ENCE, okay? So the circumference, it's pi times the diameter, which is 16 cm. And the answer is 25.12 cm. Next, we are going to find the circumference of the small circle. This plus this will give you a full circle. Therefore, circumference of the small circle, which is pi times the diameter. In this case, 6 cm. That will be 18.84 cm. So the final step to find the parameter, we just need to add this plus the vertical length, which is 8 and 8. Okay, so parameter of the shaded part, 25.12 plus 18.84 plus this and this, which is 16 cm. The answer, 59.96 cm. Moving on. Question 2. The figure below is made up of 4 squares, a circle, and a quadrant. So the 4 squares, 1, 2, 3, 4, the circle, and the quadrant here. Okay. The circle has a radius of 2 cm and it fits tightly inside the square. So the 2 cm, it's probably I can. Now if it's 2 cm, we know that the diameter will be 4 cm, which happens to be the length of one square. What is the parameter of the shaded part? Express your answer in terms of pi in the simplest form. Over here, to find a parameter, let's figure out which segment they are made up of. First, it is made up of the circumference of the quadrant here. Next, we have this horizontal length here, this vertical length here, and the last part, which is this. Some of you might be wondering, what is this? To make it clearer, probably I can do this. Now, is it easier to see? What is this? This is simply the quadrant of the small circle. Okay, so to reiterate, the parameter of the shaded part is this big quadrant, which we can find. The quadrant of the circumference of this small quadrant, which again we can find. What about this two? This two vertical and horizontal length. Well, if the diameter is 4, the radius will be 2 cm, isn't it? So this is 2, this is 4, thus the whole thing over here is 6. Okay, and this whole thing from here to here is 6. So let's find the answer right now. First, let's find the circumference of the big quadrant, alright? Circumference of the big quadrant. Which is a quarter of the full circle circumference. So it's a quarter times pi. We leave it in terms of pi, alright, over here, times the diameter. What is the diameter of the big quadrant? So we have 4, 4, which is 8. So the radius of the quadrant is 8. Therefore, the diameter have to be 16. You will get 4 pi cm. Next, let's move on to find the circumference of the small quadrant. Of the small quadrant. Again, a quarter of pi times the radius of the small quadrant, which is this entire thing. Alright, 4. That will give you, oh, a very nice number, pi. Last, we just need to add them up, plus 6 plus 6 to find the answer. Hence, parameter of the shaded part equal to 4 pi plus pi plus 6, 12. Let's simplify this answer just like in your algebra chapter. In total, we will get 4 pi plus pi, that is 5 pi plus the 12, the whole thing, cm. Okay, let's move on. Question 3. Below is a rectangular piece of cardboard. Hence, we have this initial rectangular piece. with 3 semicircles being cut out. Obviously, these are the 3 semicircles, 1, 2, 3. The diameter of each semicircle is 21 cm. Hence, this is 21, 21, and over here, 21. And the parameter of the figure below is 254. Take note, it's the parameter of the figure, not the parameter of the original rectangular piece of cardboard. Okay, so 254 is here. Maybe let me trace it out. Here, it's the final piece, okay, not the original piece of rectangular cardboard. This is 254, the entire highlighted length. That is 254, okay? Go back. Finally, what do you want us to find? What is the length of xy? Here. Step 1. Let's figure out what is the circumference of this semicircle. That shall be the first step. After that, we analyze the figure again to get a clearer picture. So, circumference of the semicircle, which is equal to half times pi times the diameter. We simplify it. We will get 33 cm. So this whole thing is 33. Maybe let me write it down here. 33, 33, 33. Okay. Now, maybe let me remove all this. Okay. Again, to highlight 33, 33, and 33. Now I'm going to give you a hint on how to proceed. What if we take this 12 centimeter and then put it here? We put it nicely here. What can we say about this length here? Here, isn't it equal to xy? How do I get it? 12 plus 33 plus xy must be again equal to 12 plus 33 plus this 2, isn't it? So this plus this must be equal to xy. Knowing this fact, how can we proceed to find the length of xy? Well, it will be easier if we can just take the parameter 254, this entire parameter 254. We subtract everything away until we are left with this xy and this xy. After that, we just need to divide by 2. Let's do it step by step. Okay. Let's see. Now, I'm just going to do it this way. X, Y. What is the length of xy? We start with the 2. Okay, maybe I give it more space. I'm going to start with 2, 5, 4. Start with the whole parameter. I'm going to subtract. How I'm going to do it? So let me change the color. Okay, 2, 5, 4. I'm going to minus away the 39 here. I'm going to minus away 39. Okay, I'm going to minus 139 over here. 39. Next, I'm going to minus away probably this 33. 33. And 33 here. So how many 33 is that? 3 of them. That will be 99 cm. What else? I can minus away the 12 cm. So minus away 12, minus away 12. That means I'll be left with, I will subtract another 24. Am I done? Not yet. I'm still left with this two thing over here. This 21 is out of the picture, okay, since it's dotted line, so let me remove it. Okay. What are these two lengths? Remember, initially this whole thing is 39 cm, and we know that this being the diameter, which is 21. So this and this is equal to 39 minus the diameter, which is 21 cm, and that will give you 18. So this two length over here is minus 18. Minus 18 cm. Let's remove it from the picture. Okay, so minus 18. Finally, we are done with the isolation. We are now just left with xy and another xy. Okay, this two thing. Okay, here plus here is xy. After that, what do we need to do? This is equal to 2xy. So we just need to take this whole thing divided by 2. Then we should get the answer, which is 37 cm. Okay, now for this question, you need a bit of analysis and you need to break it up into segments like how I did it. Alright, once you break it up into segments, you start to isolate until you are left with the xy and this second xy. After that, you just need to divide by 2. You need to have a systematic approach. Okay, so you subtract one length at a time. So I started with the 39 cm here. Then I removed the 3 semicircles. After that, I removed the 12 cm over here and the 12 cm over here. Lastly, I removed the 2 lines over here, which is 18. Then I divide by 2. If you need, please watch the video again. Try it out on your own until you understand. Okay, so let's move on to question 4. Question 4. The figure below is made up of 9 identical squares and 8 identical circles. Okay, so you can count it on your own. Find the area of the shaded part. Take pi to be 22 out of 7. They have listed here that the length of the square is 42 cm, which is 3 diameters. Hence, we can see that one diameter is 14, isn't it? Which means the radius is 7. Alright, so let's proceed. One way to solve this question is simply to rearrange the given shape. In particular, we are going to rearrange the shaded portion. This is a nicely drawn, nicely shaded square, so we just leave it. The only thing we need to care about is this tiny little part. So how many are there? Let's zoom in. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of it. So you look at this. This is 1, 2, 3, 4. Are we able to rearrange this 1, 2, 3, and 4? We can, right? So in total, there are 12 parts. So let's rearrange in this manner. How about, let me just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are done with all the 12. We have rearranged all this tiny shaded portion into here. So it's much easier to calculate. After you have shifted it over here, all this would simply become a empty square, isn't it? So this is 1 square. This will be an empty square. Okay, the covering is not perfectly fitted in, but you get the idea. This is gone, and since this and this have shifted up, this and this have also shifted up, they have become this and this. Okay, now how do we find the shaded part? We just need to take the entire square, 42 times 42, the entire area of the square. We subtract 1, 2, 3, 4, 5 small squares and 1, 2, 3 circles. Then we are just left with the shaded part. Okay, so let's start. First step, let's find out the area. Okay, let me make it smaller. Area of the figure, which is the entire big square. 42 times 42, and that is 1764 cm square. Second step, let's find out the area of 5 small squares. Yeah, I think I can call it small squares, okay, to have no confusion. 5 small squares. Why 5? 1, 2, 3, 4, 5. So what is the area of 1 square? It's the length, it's 14, isn't it? Radius is 7, so this whole thing is 14. So 14 times 14, that will give you the area of 1 small square. We want to have 5, so we multiply it by 5 to give us 980 cm square. Next, we're going to figure out what is the area of 3 small circles. So area of three circles will do. All right, there are no other circles to be confused with. So area of 3 circles. Area of 1 circle is pi times the radius times the radius. Okay, so this is the radius, 7. And this is 1 circle, so we need to times 3. The answer will be 462 cm square. Finally, moving on to the answer, area of the shaded part, which is equal to 1764 minus 980 minus 462. 322 cm square. Okay, so to summarize, we need to shift the shaded part around so that it's easier for us to manage. Right now, once I've shifted all this small little shaded part, up here, all this will just become blank squares. Okay.